All right, so this is the first part of our um, PowerPoint over data analysis. So let's get started. When we talk about chemistry and we talk about um, the math involved, the first thing we need to discuss is what is a unit? And as you can see by the definition there, and I'm not going to read it to you, you can see that for yourself, but a unit is anything that you put after a number to represent some sort of measurement. If I say that I'm 6 feet 2 inches, then feet and inches are my units. If I say I'm 200 pounds, pounds is my unit. If I say that we are 5 miles from the state line, miles is the unit. The unit is there because the unit gives the number meaning. If I told you that I weigh 200 and that was it, well, 200 what? 200 pounds? 200 newtons? 200 kilograms? What? You have to give the number some meaning. If I walk outside and I say, well, the temperature out here is 35. 35 what? 35 degrees Fahrenheit? 35 degrees Celsius? 35 Kelvin? I hope it's not 35 Kelvin. So when we're talking about measurements, we give measurements meaning by adding units. And of course, you can see the funny comic there. Hilarious. So what type of measurement system do we use in science? Well, we use the SI system. SI stands for Systems International. It started in France, so that's why it kind of is, sounds odd. Instead of saying international systems, it's the System International. So we call it the metric system, but in science you used to say it's the SI system. Science across the globe use the metric system. There's only a few countries that haven't officially adopted it, and we are one of them, Myanmar and Liberia. The entire rest of the world uses the metric system more than any other measuring system, except for these 3 countries. There's many reasons why we still haven't converted officially to it. And you think about it, we see it in our everyday lives. You go buy a 2-liter bottle of Coke. Well, there you go. Liters is a unit for the metric system. We don't go buy gallons of soft drinks. If you look at any label at the store, it's typically going to give you a metric unit. If you look at a Coca-Cola can, for instance, it might say 12 fluid ounces being the English unit, but there's also 355 milliliters on it. So milliliters, a metric unit, is still there. It's just some people just overlook it. So really one of the main reasons is just we don't want to change. We like it the way it is. We like the English system. We like inches. We like feet. We don't need centimeters. We don't need meters. We don't need kilometers. We don't need these other units. So there's a bit of being conceited about it. But that's just the way it is. In science, though, metric system is what we use. A base unit, there are 7 of them, 7 base units in the metric system, in the SI system, and every base unit represents a different quantity. So we have meter, which measures length, kilogram, which measures mass, second is time, ampere is electric current, Kelvin is temperature, mole is amount of substance, and candela is luminous intensity. In chemistry, we really won't use the candela that much. We really won't use the ampere that much. meter somewhat, but definitely kilogram, and definitely mole, and we use Kelvin quite a bit, although we use degrees Celsius too. The symbols over here, you might notice that kilogram, it's not just gram. Well, each of these values has a standard of that's there's officially something that's called a meter. There used to actually be an official meter stick. There still is, but that's not the official definition anymore. But there was never an item that was just a gram. There was always, and there still is, an official kilogram. So even though kilo is a prefix, kilogram is still considered the base unit, even though gram should be the base unit. A lot of the definitions, the current definitions for these things, are more physics-based. I forget exactly, but a meter is the amount of distance light travels in a certain number of nanoseconds or something like that. It's not that important for you guys to know, but just understand that these do have official definitions. They do have a standard and we might see some videos in class about that. Now, if you take any of these and you combine them to represent another type of measurement, you call that a derived unit. For example, the unit for acceleration is a meter per second squared. So if you have a meter, if you have a meter, well, we know meter is the base unit for length. Per second squared. Well, now that's comparing the amount of distance you go over a certain time, or actually it's the change in speed over time is what it is. But it's got a distance on the top and it has time on the bottom. So this is combining two base units. It's combining the meter and it's combining the second. So because it's combining these two things, we call it a derived unit. Density is another example. Gram per milliliter, let's say. Gram per milliliter is the unit for density. But as you can see, and it's hard to see where the base unit is, milliliter is equal to centimeter cubed, so that's three-dimensional meter, or centimeter. And then gram is a modified version of the base unit, kilogram. But you take any of these, and it doesn't have to be two different ones. For example, a meter cubed, a unit for volume, that's a derived unit because it's using meters in 3 dimensions. Okay. All right, that's part 1 of the data analysis notes.